Hello and welcome to this video that is going to teach, model, and explore some of the properties with exponents, specifically the properties involved when you are multiplying variable expressions that have the same base. Okay, now this video has a lot of examples, so the way I produced it when I uploaded it to YouTube was to put the time signatures next to some of the words on this slide. So you can kind of pick your level that you want to see things at. You can watch the whole thing, or to save some time, you can scroll right to the section that corresponds to the title and sort of the table of contents here on this slide. Okay, so you may want to pause the screen for a second and be able to read and look at the examples. They're done later in the video, and you can sort of pick the level you want to start at. I'm hoping you have a little bit of background on this, but also the video is meant to be comprehensive for people of a wide variety of levels. So let's go here into the basic property and explanation of when you are multiplying variables of the same base. And just from the real basic idea, we have that x times x is x squared. Okay, and this should not be too odd for those of you that grew up thinking something like 3 times 3 was equal to 3 squared. Okay, so if you notice here, what is happening? We have x to the first and x to the first becoming x to the second. So it stands to reason that maybe what you're doing is you are adding those exponents. In fact, you are. So the actual property here that we talk about is when you're multiplying x to the a times x to the b, where a and b are real numbers, you have x to the a plus b. Okay? So also, what you want to realize here is that it's commonly read that when you are multiplying variables of the same base, you in fact just take the exponents and add them. Also, if you had coefficients, something like 3x to the a times 2x to the b, you would take your 3 times 2 and make a product of 6. Okay, so let's get into some easy examples and then move on in levels of difficulty as the video progresses. Okay, so again, I've copied the property up here that you want to be cognizant of as you do this. It's x to the a times x to the b is equal to the x to the a plus b. And sort of just some sort of steps that you want to visualize as you're going through the problems. You're going to multiply the coefficients, write the base, and add the exponents. So the directions say, please simplify, write your answer with positive exponents. In these easy examples, this won't be so much of an issue. I will try to color coordinate these with the colors that I have up here. So here in number 1 it says 5a squared times 3a cubed. So we will in fact multiply the coefficients of 5 times 3 and get 15. We'll write the base, which in this case is a, and we'll add the exponents. 2 plus 3 will be 5. Okay? And just as a quick explanation as to this, as it's still in the easy examples and how it relates back to the basic principle, if I expanded this, I would in fact be saying that 5a squared is 5 times a, and then times 3a cubed, which is 3 times a times a times a. Now from here, it's much easier to see that we do have 15, then we have a to the 5th, and that we have 5 factors of a. So just an example there that you can always go backwards, okay? But I'm just erasing it so you don't think that's how you do the problem. But you can, when you're stuck, sort of say, you know, how can I kind of go backwards and maybe go the long way and remember the rule if you're having problems remembering it. Okay, so in example 2, we have negative 4x to the 7th times negative 3x to the 5th. And again, we're going to multiply the coefficients, which negative 4 times negative 3 will be 12. We'll write the base, which in this case is x. We'll add the exponents here getting 7 plus 5 is 12 for an answer of 12x to the 12. Okay, in this next example where we have d times d times d times d, I tend to think it's an easy example, maybe a little harder version of an easy example. One thing you need to remember is that these are all d to the first. Okay, a little confusing sometimes because when you don't see the exponent, you want to say it's 0 because you don't see it. But exponents and coefficients that you don't see tend to be 1. So here, following the idea of multiply the coefficients, well, they're all 1, so I'll just use the magic pen there. And let it fade out, write the base, which is d, and add the exponents, which obviously will be 4. Okay? So we'll continue to move on here and go on to some medium examples. Hi, if you've just scrolled here and we're in some medium examples, we will be taking a look at these problems and applying these steps again, which are multiply the coefficients, write the base, add the exponents, because that's kind of a mental map for this property, which says when you are multiplying same bases, you can take the exponents and add them when you're simplifying. So the directions say, please simplify, write your answers with positive exponents. Okay, just a little preview on these problems. You have some negative exponents. Don't be bothered by them so much here. The place where you'll have to write your answers with positive exponents occurs a little bit later, and you'll see as these problems progress what I mean by that. Okay, so in this first problem, it says negative 2/3 xy squared times 3/11 x to the 7th, y to the 5th. So we are in fact going to multiply the coefficients. I'm just getting my calculator ready in case I need it. Okay. And I see here that I have negative 2/3 times 3/11. Well, I know negative times positive is negative. And then if I just use my fraction rules, I realize I can cancel the 3's and get 2/11. If you're uncertain about that, just model this over here on your calculator. You can do negative 2/3, excuse me, negative 2 sorry about that. I just had a little technical snafu there with my mouse. So we have negative 2/3 times 3/11, and you hit math, enter, enter to make sure it's a fraction. So I'm just trying to show you that that is in fact a backup if you're weak with dealing with fractions by hand. Okay, so then we will write the base. Notice we have multiple bases here because it's a medium example. So I'll write the x, and then I'll add the exponents, which the exponent here is 1. The exponent here is 7, so that's going to be x to the 8th. Then we're going to write the next base, which is y, and add those exponents, which 2 and 5 is 7. Okay? Now in this next example, don't let the fact that it has parentheses as opposed to the dot, it's still multiply. There's no distribution going on here, in case that throws you off. So we have 4a to the negative 6, b to the 12th, times 7a to the 6, b to the negative 5th. If you're familiar with the negative exponent rule, I wouldn't apply it just yet. I would do my multiplication property, which is being featured in this video anyway. So we'll see here what we've got for 4 times 7 is 28 for multiplying the coefficients, and I'll write the first base, which is a. And you notice here you're going to get a to the 6th times a to the negative 6th when you go to do that, and you'll see that that is in fact a to the 0. Okay, I'll pull that out in the margin in a second to talk about that. Write the next base, which is b. Add the exponent, which is 12 and negative 5 gives us 7 when we add. And you need to remember the property that anything to the 0 power is equal to 1. Okay, now I could have seen the a to the negative 6 and a to the 6 and crossed them out. cross out's not an actual math operation, but you can see where this is going here, that if this in fact is just 1, 28 times 1 times b to the 7th would leave me with 28b to the 7th. Okay? So not totally necessary to show this piece right here, but I just, for the sake of reviewing it, did. You could have gone right to 28b to the 7th if you're fluent in this skill. Okay, so on the next example, we have 0.23 a to the negative 8th b to the 12th times 4.7 a to the 9th b to the 5th. Well, I am going to use my calculator for that. When I go to multiply the coefficients, obviously I'm going to get 0.23 times 4.7, okay, which is 1.081. I don't have to convert that to a fraction because I can write 1.081 without rounding it. It's not obnoxiously long. Write the first base, which is a, add the exponents, which are negative 8 and 9, which gives us 1. If you don't have to write the 1, kind of why I picked this example to move this way, to kind of reaffirm that you do not have to write the exponent of 1 in your final answer. So I'll move over to the next base, which is b, and 12 plus negative 5 is, in fact, 7. Okay? So I'll move on to some harder examples now. So welcome to the harder examples if you've just scrolled here. I'm going to try and move through these kind of, again, looking at the property that we talked about on the first slide, which talks about if you're multiplying variables of the same base, you take the exponents and you add them together. So sort of the mind map I use here a little bit is multiply the coefficients, write the base, and add the exponents. Now, if you've watched the previous two slides and you're here, you realize that this little box is something I'm doing in all the problems regardless of their difficulty level. So it's a very strict policy. It's a sort of a set rule, and even though the problems look like they're getting harder, I am in fact doing exactly what it says every time. There's just subtleties in the problem that increase the difficulty level. Okay? So here, please simplify. Write your answer with positive exponents. So in this first example, we have negative 4h to the 3a times h to the 6a. And don't fret when you see these variables that are exponents as well. You're still going to follow this idea up here. So look, we're going to multiply our coefficients, which in this case is negative 4 times 1. We're going to write our base, which in this case is h, and then we're going to add our exponents. And if you're just unsure of yourself, write it in the margin. 3a plus 6a is 9a. Okay? So the answer is negative 4h to the 9a. Now, kids that tend to get this wrong because they're dealing with exponents want to write 9a squared. But that is not the case because a plus a equals 2a. It's not the case that a plus a equals a squared. Okay? So that's just a common mistake we see a lot when kids do these problems. So in example 2, where it says 1/7 y to the 5a times 14/3 y to the negative 7th, we will, again, multiply the coefficients, which in this case is 1/7 and 14/3. And I'll just simplify using least common factors, or excuse me, greatest common factors of 7 and 14, which is 7. Okay? Then multiplying across for my fraction, I'll get 2/3. Then I'm going to write the base, which is y. Then I'm going to add my exponent, and if you want me to write it in the margin for a second, I will. And what's 5a plus negative 7? Well, they're not like terms, so it's just 5a minus 7. So the answer is 2/3 y to the 5a minus 7. Okay? So, and in this last example, we have 0.89 y to the 2a minus b times y to the 3a plus 6b. Okay, just going to continue to move through this idea up in this box, which kind of manifests this property and applies this property here. So I will multiply our coefficients, which is 0.89 times 1, so it's just 0.89. And then I'm going to write the base, which is y. And then, don't be freaked out, I'm just going to add the exponents. I'll write it in the margin. If you can do it in your head, great. 2a minus b plus 3a plus 6b, which will give me 5a, and then positive 5b when I combine like terms, making the answer 0.89 y to the 5a plus 5b. Okay, so if you notice, we've pretty much scrolled through some difficult examples here. Uh, if you've watched the whole video, we're hopping up the level of difficulty. Now, the only thing I could do, I think, to make this even more difficult is go into problems where the negative exponent rule comes into play. So if you're watching now, it assumes you kind of understand the negative exponent rule. And the crash course in that is that x to the negative a is equal to 1 over x to the a. Also, 1 over x to the negative a is equal to x to the a. Now, I probably have a video somewhere else on this. And this video is meant to sort of review the sum total of things you'll encounter when you're multiplying same bases. Now, that also should, if you're in a Algebra 2 or Trig Pre-Calc class, that should bring you up to doing it with negative exponents. So you should need to apply this rule. As you read the directions, it says, please simplify. Write your answer with positive exponents. That's where you're going to have to pay attention to this rule. Now, this rule does not go away. The property still says when you're multiplying same bases, take the exponents and add them. So multiply the coefficients, write the base, add the exponents, being mindful if we have negative exponents when we're done to do this property. Okay? So now you see a negative exponent in this first example right here where it says 5x cubed times 8x to the negative 9. Okay? Well, I'm not going to do this property just yet because you never know. If you do your multiplication property, you might cancel the exponent. It's negative. We saw that before, so I'll take my time here and size the problem up and say that I'm going to get 40 when I multiply the coefficients, write the base, and unfortunately I'm still getting a negative exponent. So we see here that the base of x has a negative exponent, so I am in fact going to flip that into the denominator and change the sign of the exponent from negative to positive. And our final answer is 40 over x to the 6. Okay? Now in this next example where it says the opposite of a cubed, b to the negative 7th, times 8b to the 8th, a to the negative 3rd, I'm still going to be religiously trying to apply this idea. So I'm going to multiply my coefficients, which is negative 1 and 8. That's going to give me negative 8. And I'm going to write my first base, which is a, and then see that 3 plus negative 3 is going to give me 0. Now be careful here because the order of these, the AB order is reversed in the second factor, so just be careful. And then I'm going to write b to the negative 7 plus 8 will give me 1. So we really didn't have to deal with the negative exponents in this so much because my final answer is just going to be negative 8b. Okay? Now, in example number 3, again we see negative exponents. Now, you could apply this rule, but if you just kind of size it up for a second and say, well, I've got these negative exponents here with this y that don't look like they're going away when I'm adding more negative to it. So instead of trying to do the flipping negative exponent property, let's try and do the multiply property and condense the problem a little bit. These problems really have a feel to them, so you have to do a lot of them. That's why I'm kind of doing a lot of examples in this video here. So I'm going to multiply the coefficients and get negative 14. Then I'm going to write my first base, which is x, and then add my exponents of 8 and negative 9. That's going to give me negative 1. And then I'm going to write my next base, which is y. and then I'm going to add my exponents there, which is negative 5 and negative 10. So it's going to give me negative 15. And then I notice that I have two bases that have negative exponents, so I'll do this property here and flip both of them. Okay? And you need to realize something here. Although this 14 is negative, it is not an exponent. If you notice up here in the property, it's when the exponent is negative that you apply the flipping it over reciprocal property here. Okay? So with that, you need to realize that I'm not going to flip the negative 14, and I'm just going to get negative 14 over x to the first, which I don't have to write the first because it's kind of redundant or superfluous at least to say it. And then I'm going to write y to the 15th, changing the exponent from negative to positive, which adheres to the directions of writing your answers with positive exponents. So I hope that this was a help to you. I hope the way that I laid this out was well done and you jumped in at your difficulty level where you felt it was appropriate. Trying to integrate the idea of these negative exponents along the way, at least show them the harder problems where you have to do the negative exponent property. Because like I said, if you're watching this video, you should have seen all of these properties already before, and this is some review, and it's hard for me to produce a video that's kind of from scratch and has a high difficulty level at the same time and make it short. So hopefully the way I laid it out was useful. Okay, so take care and practice hard, and feel free to watch all the parts you want to watch over again as many times as you want.